Greetings, everyone. Welcome to today's presentation. Replica offers both synchronous and asynchronous replication solutions. With the features of Replica 3.0, disaster recovery can be easily and simply implemented across QSAN platforms. This webinar will introduce the concepts and detailed processes of synchronous and asynchronous replication to achieve optimal DR mechanism practices. Disaster recovery aims to prevent complete failure of critical business systems and restore them in the shortest time possible, minimizing the impact. Preventing data loss requires continuous data protection methods, including recovery from human errors, hardware and software failures, network interruptions, internal or external power failures, and other incidents. To address this challenge, IT administrators must plan for redundancy by setting up one or more backup systems in different locations, involving continuous or periodic replication of data to different locations to ensure business continuity and sustained availability. In today's multi-platform environment, backup operations are often constrained by the architecture and resources of a single platform, leading to reduced flexibility and increased costs. This webinar will also demonstrate how to use QSAN's XEVO and QSM4 products to implement a cross-product async replication backup solution, breaking platform limitations, enhancing backup flexibility, and effectively reducing costs. We will provide detailed product features and step-by-step setup demonstrations. Let us guide you through exploring a more flexible and efficient data protection solution. RPO and RTO are the two most important parameters in a disaster recovery. To achieve continuous data protection, you must understand these two key indicators that measure acceptable business risk. These goals can guide companies in choosing the best data backup plan. RPO refers to the maximum amount of data loss that the system can tolerate. It refers to the time point corresponding to the recovered data after the business is restored. The RPO depends on the update level of the data recovery. This update level can be the last day. The backup data can also be 1 hour ago data. This is related to the frequency of data backup. In order to improve RPO, the frequency of data backup must be increased. RPO is an indicator that reflects the integrity of data restored. RTO is the duration of time the system can tolerate service interruption. For example, if the service needs to be restored within half an hour after the occurrence, the RTO value is 30 minutes. The RTO is only the time period between the occurrence of a failure from the moment when the system goes down and the application stops to the time when it is restored to support the operation. RTO is an indicator reflecting the timeliness of business recovery. It indicates the time required for business to recover from interruption to normal. The smaller the RTO value, the stronger the data recovery capability of the disaster recovery system. The IT administrators can deploy many disaster recovery systems. Obtain the smallest RTO, but it means investing a lot of money. The RPO indicator comes from before the failure occurs, and the RTO indicator comes from after the failure occurs. The smaller the value of the two is, the time interval can be effectively shortened from business transition period to normal. Traditional backup and recovery techniques, such as tape backup or disk-to-disk, are measured in hours. It will take a long time for them to recover, such as several hours to several days. Disaster recovery techniques such as asynchronous replication are usually measured in minutes. In the event of an accident, the recovery time will be reduced to a few minutes. Another more stringent business continuity goal is measured in seconds, usually with no data loss at all. Synchronous replication technology can achieve this. Asynchronous replication is a block-level, differential remote volume backup function through LAN or WAN. In the beginning, replication will copy all data from the source volume to the target. It is also called a full replication. After that, use snapshot technology to perform incremental replication. Asynchronous replication uses the ISCSI function to establish a replication connection. It can use the full bandwidth of the allocated network port to achieve the best backup speed. However, in order to balance replication traffic and non-replication traffic, the traffic shaping function can help reserve the necessary bandwidth for non-replication I/O. Asynchronous replication can achieve the same data protection goals. However, the method and frequency of data replication are different from synchronous replication. Asynchronous replication commits writes at the source and then send the acknowledgement to the application on the host. The accumulated writes committed on the source volume will be copied to the target volume in batches at scheduled intervals. Synchronous replication is a block-level volume backup function through LAN or WAN. It is a timely replication function that can always synchronize source and target data. It uses ISCSI function to establish a replication connection. The replication task can use the full bandwidth of the assigned network port to allow the best backup speed. We assume that the synchronization source port must be greater than or equal to 10 Gbps to ensure normal operation. However, the synchronization source port in the source storage is not limited to the dedicated one. In order to balance replication traffic, it is still recommended to separate the port of incoming data from the host and the synchronization source port to the target storage. Synchronous replication can ensure data consistency between the replication source and target. This can be achieved by ensuring that every write I/O requested from the applications on the host will be completed after the host obtains the confirmation between the source and the target. If the write I/O cannot be committed on the source or target, the write operation will not be committed to ensure consistency. In addition, write failures are sent back to its applications on the host. Then, application error handling will determine the next appropriate step for the pending transaction. 1. The application on the host sends a write request to the source volume. 2. The write I/O copies to the target volume. 3. The write I/O at the target is committed to the target volume. 4. The write commit at the target is confirmed back to the source. 5. The write I/O is committed to the source volume. 6. Finally, the write acknowledgement will be sent to the application on the host. When a user creates a synchronous replication task, it will automatically copy all data from the source volume to the target at the beginning. This is also called full replication. At the same time, the source system will record a fracture log to maintain the block whether has been synchronized. The fracture log is a bitmap saved in the source storage to indicate which block of the source have been updated. Synchronous replication is a block-level volume backup function through LAN or WAN. It is a timely replication function that can always synchronize source and target data. It uses ISCSI function to establish a replication connection. The replication task can use the full bandwidth of the assigned network port to allow the best backup speed. We assume that the synchronization source port must be greater than or equal to 10 Gbps to ensure normal operation. However, the synchronization source port in the source storage is not limited to the dedicated one. In order to balance replication traffic, it is still recommended to separate the port of incoming data from the host and the synchronization source port to the target storage. Synchronous replication can ensure data consistency between the replication source and target. This can be achieved by ensuring that every write I/O requested from the applications on the host will be completed after the host obtains the confirmation between the source and the target. If the write I/O cannot be committed on the source or target, the write operation will not be committed to ensure consistency. In addition, write failures are sent back to its applications on the host. Then, application error handling will determine the next appropriate step for the pending transaction. 1. The application on the host sends a write request to the source volume. 2. The write I/O copies to the target volume. 3. The write I/O at the target is committed to the target volume. 4. The write commit at the target is confirmed back to the source. 5. The write I/O is committed to the source volume. 6. Finally, the write acknowledgement will be sent to the application on the host. Both synchronous and asynchronous replications have their advantages and disadvantages. Before choosing a backup method, you must understand the risks of disaster recovery. Synchronous replication ensures that every data written to storage is saved locally and remotely. This can ensure zero data loss in the event of a disaster. So RPO is zero. In a synchronous replication solution, there are also trade-offs. Since each write needs to be saved locally and remotely, any problems affecting the source or target storage or the replication link between these two will affect the application in terms of latency and availability. As the distance between the source and target increases, this response time also increases. It is recommended to ensure that the link delay between the source and target is less than 10 ms. The converted distance is about 100 kilometers. Synchronous replication is mainly used for mission-critical applications that require instant failover when the source site fails. Although synchronous replication is usually used for disaster recovery, it is preferred for applications that cannot tolerate data loss and have a short recovery time. Asynchronous replication is mainly used to replicate data over long distances. It does not affect host I/O latency because once host writes are saved to the source storage, they are acknowledged. Since write operations are not immediately copied to the target, all writes will be tracked on the source. This data will be copied during the next synchronization. Therefore, RPO should be an acceptable amount of data, which may be lost due to failure. An RTO is equal to the period of the next synchronization. This time increment also affects the amount of data that needs to be replicated during the next synchronization and the amount of potential data loss in the event of a disaster. Of course, the perfect solution is that both RTO and RPO are 0. This means that when a fault occurs, the system will respond immediately and there will be no data loss. To achieve this goal, the system design is extremely complicated and the cost is very expensive. So it should avoid falling into the vicious circle of simply pursuing the improvement of the two indicators and combining the actual situation. Appropriately improving the two indicators according to local conditions is the right way. This is the environment architecture diagram that we will demonstrate later, which can be used as a reference. Create a pool and source volume in XEVO, then create a host group and add the volume to the host group. Create a pool and target block volume in QSM4. Change the volume type to replication, then create a block host group and add the volume to the host group. Go back to XEVO, create a protection group, and select the source volume. Enable replication and choose the deployment method and schedule. Enter the IP address of QSM4 as the target side, then select the target backup volume and apply. As shown in the image, the async replication task has been successfully created and will perform backups daily at 0 o'clock as scheduled. When XEVO stops working or experiences a power outage, log into QSM4 and first remove the backup volume from the host group. Change the replication volume to a RAID volume, then re-add the RAID volume to the host group. Mount the RAID volume to the host to restore service applications or virtualization applications. The asynchronous replication solution from XEVO to QSM4 offers an ideal balance between performance and cost effectiveness. By utilizing XEVO as high-performance primary storage and QSM4 as the disaster recovery solution, businesses can ensure data resilience while controlling costs. This setup is particularly beneficial for companies seeking a reliable disaster recovery solution, as it minimizes service downtime and keeps business operations running during power outages or other disasters. The combination of advanced replication technology and affordable storage makes this solution a strategic choice for businesses looking to enhance their disaster recovery capabilities without exceeding their budget.